Hi, everyone. My name is Sonika Tyagi, and I'm here with Ashish, and together we'll take you through what we want to build to do personalized risk prediction for adverse pregnancy outcomes. So adverse pregnancy outcomes such as gestational diabetes, preterm birth, fetal growth restriction, gestational hypertension, stillbirth, they are a global health concern and lead to a very high, I want to have the, anyway, I'll just use this, a very high maternal and child mortality. And preterm birth of these affects 1 in 5 Australian pregnancy and 14% of indigenous pregnancy. And these come with a lot of other comorbidities as well, chronic illness, disability, psychological impact. And looking after the neonatal babies is a huge cost both on healthcare and the affected families. So we need a solution to address these health challenges. And what we realized during this research is that we don't have a comprehensive pregnancy-specific repository where we can find all this information and relationship between different research outcomes and in healthcare interventions. So this is what we decided to tackle in this particular project. So we, through collaborative funded NHMRC grants and research, we have developed Australian cohort of for studying term and preterm labor and have built probably the largest biobank of understanding molecular underpinning of how labor starts for human childbirth, and have this this data is complemented by another graduate research by Murali, where he has done meta-analysis of 20 or so publicly accessible healthcare data. And more recently, I have collaborated with an industry and an SME, and through their collaboration, we are focusing on collecting more health data and especially focusing on culturally and linguistically diverse women. So with this, we should have a comprehensive data bank, and what we are thinking that now this information can be overlaid with other unstructured information that we can gather from biomedical literature, clinical reports, healthcare intervention, public health reports, and so on. And with that question in mind, we have these objectives in this particular project where we want to collect these data through automated text mining and connect this with the molecular and clinical data that we have been collecting. And then probably build an interactive knowledge base where we can query that knowledge base, find this linked information that we can use for new research and development and eventually for clinical decision making. And with that, I would hand over to Ashish, who's been doing all this fantastic work, and he will explain the methodology. Yeah.
Thank you, Sonika. So this is our methodology pipeline. In the first step, we went towards data collection. So in this step, we built a custom script which uses semantic API, and we were successful in collecting over 14,000 pregnancy-relevant abstracts from biomedical literature. After this, we fine-tune an existing SciBIRD model, which we term it as PregSciBIRD. What it does is that it can classify relevant pregnancy abstract, and we can get high-quality abstract from it. And through manual inspection also, we were able to choose 100 abstracts. So this is for the initial run. These abstracts went through whole workflow of this. We went through pre-processing, cleaning, and filtering stop words, and then entity and relationship extraction from the unstructured text, which we term it as PregNER, name entity recognition, and then map it to a standard vocabulary, which is ontology mapping, standardization, and at the end, we have a complete knowledge graph. And we also will be presenting it through a web-based interface. So whole of these workflow will be going through a continuous feedback and integration. Moving forward towards the results. So entity and relationship extraction from abstract, we went through two processes combined. So first is use size-spacey pre-trained models. These generally work on a rule-based system, and another is LLMs. So through LLMs, we have been able to acquire better results. So over there, we can see the entity types, DNA, cell type, cellular components, all of those entity types, and then specific relationships, association, positive correlation, and etc. So this is our exact screenshot of what we were able to get from one abstract. So all of the triples are there in the format shown. So coming towards ontology mapping, we have used Unified Medical Language System, UMLS, which brings together many health and biomedical vocabularies and standards. So our abstracts and the triple through LLMs have gone through UMLS mapping. So at the top, we can see two clusters. Those are clusters which are not mapped to UMLS. These are all the embeddings which are gone through dimensionality reduction. And then we can see the entity type, the semantic type over there, which are all custom. And at the end, we have mapped it to UMLS. But we can see the blue dots are more, which relates that there are a lot of unknown entities that we need to map, which need to be resolved. And that is how the mapping looks like, entities from triples to UMLS format. So we have used Protege, which is an ontology editor. So the classes are as follows, and the relationship in the software that we can see. So coming towards our visualization of the graph, I'll play this on. So this is how it looks. We can also have a live demo later on, but this is a snapshot from our interface. So all of these we can see are the entities and the relationship, and there is the query interface with, we can choose preterm birth or hormones and find relationship through all the entities, which can be zoomed in or zoom out. It's quite interactive, and we can also see what are all the relationship that we have till now that we have found out, and also focus on certain entities. So over here, if you see labor, so for labor, these are all the biomarkers, or you can say what are the relationship with a lot of other entities. So this is our visualization of the graph.
And I'll just add one more thing, that we were able to reproduce the entity relationships that we picked up from the existing literature, and then we could also find some new relationship through building these graphs. And we plan to then further analyze this more systematically to see what other gaps we can fill in the knowledge. Yeah.
Yeah, so I'll hand it over to Sonika.
Okay, it's my turn anyway. Okay, I'm good. Okay, so through this process of building the knowledge graph for pregnancy, we have obviously encountered several challenges at the technical level. So we need to look at more optimized pregnancy-specific name entity recognition, because a lot of the tools and the workflows that we find are more English language specific. So we need to tune them to identify clinical language. So for example, there are some short-term terms that are used in clinical language. There are some very, very medical specific terminology. So we need to account for those when we are doing entity relationship modeling, and all these usual sort of challenges working with the LLMs that Damiano and Tim also mentioned earlier. So that is there, and then ontology mapping. So as in the literature, so the biontology subject has been around, and there's a lot of research that exists. There are a lot of rules that you can just pick off the shelf and start using, but most of this is tuned towards biomedical entities, the name of biomolecules, how the molecular pathways, and combining that with health and digital health and intervention information. Those are the parts that are not captured very well when we use those existing rules. So we are planning to take more data-driven approach, and then there's some initial testing with the LLMs has been promising, and we are planning to also apply RAG to improve this LLM based mapping. And we have a dedicated student intern now to also help us manually validate some of these tests with the LLMs. And there's another master's thesis project that is going on in my lab who is optimizing the ontology mapping side of things. So we already have, actually just last week he presented the results. So we already have, so we have been testing the T5 and the BERT models mainly for ontology mappings. And again, can we do this in more data-driven fashion so that we can capture the maximum biological knowledge possible from the documents? So that's where our current status is. And eventually, as I said, we will, with the given data set, so currently we have only developed the workflow with the highly selected abstracts that we found from the literature, but we will expand that to the rest of the 14,000 abstract that Ashish has already collected, and then start including other type of documentations. We'll analyze the graphs to find new knowledge and build a web interface so that you can query that for various type of information. And and eventually we have very first pregnancy-specific knowledge base. And with that, can't thank enough Mohammed, who's been working very, very closely with Ashish, and fantastic, very transparent, clear communication. So amazing teamwork here, and Patrick and the rest of the RaceHub team. I truly mean it. Like, you guys make us feel that you actually want to help and are not just doing your job. So we truly, truly appreciate that support. We can't do any of this work without your help. And we aligning with the RMIT and EIP's goal to leveraging technology to solve real-world problem. It will have a real impact on these women and family who are going through all these pregnancy-related complications. So with that, I'd like to thank you all for your attention.
Sonika, thanks for the session. Thanks.